We will be going through College Board's SAT Test 5, going through the math section here, showing you the best way to answer all of the questions. The best way to take advantage of this video would be to try SAT Test 5, sections 3 and 4 on your own time, and refer to this video for the most effective ways to answer each of the questions. Let's go ahead and get started. Here we have question number 1, giving us a nice simple line with a y equals mx plus b format. The y-intercept of the line is 1. It's hitting the y-axis at 1, and it's got a slope of 1 over 1. Its slope is rise over run as you go from left to right, and this line here is rising 1, and running 1. So it's a nice simple line with a slope of y equals 1x, which is just x, plus 1. So the answer to number 1 is going to be D. Number 2 here, we have a circle, center O, circumference is 36. Well, circumference is the formula 2 pi r. They're telling us that's equal to 36. So from that information, we could find the radius, but even easier than that, a 90-degree angle means a 90-degree angle here. And because this, let me draw it a little bit better here. Because this blue angle and this green angle are a linear pair, they have to add up to 180. So this is a right angle as well. Same thing for this angle and this angle. They have to add to 180, which means this is a right angle. So each of these 4 angles, let's call them angle 1, 2, 3, and 4, all are equal fourths of the circle because the circle has 360 degrees in it, and 90 out of 360 is 1 over 4. So any of these arcs out here occupy 1/4 of the circumference of the circle. So the one we're being asked about is AC, this one, and it's no different than the rest. So the length of arc AC is 1/4 of the circumference, which we already knew was 36, and that's going to be 9. So the answer to number 2 is going to be A. Number 3 now. What are the solutions of the quadratic equation that's given here? You're always going to benefit whenever possible by looking for a GCF. So always look for GCFs. Here, all 3 of these terms are divisible by 4. If I divide both sides of the equation by 4, which would look like that, dividing every single piece by 4, we get x squared minus 2x minus 3 equals 0. Now we can go ahead and factor, where this is a situation for BC factoring, because we've got numbers in this spot and in this spot, but we have no number here, or we do have a number, it's actually the invisible number 1. So we have something in the B and C spots of a quadratic. A quadratic's usually in the format of ax squared plus bx plus c. So to keep it simple, we're looking for 2 numbers that add to b and multiply to c. They need to add to -2 and multiply to -3. What 2 numbers add to -2 and multiply to -3? The answer is -3 and 1, so this factors to x minus 3. X plus 1. Now the zero product rule says if these 2 things here multiply to 0, then you set each one equal to 0. So x minus 3 equals 0, x plus 1 equals 0. Add 3 to both sides, take away 1 from both sides, and we have 3 and -1, and the answer to number 3 is going to be B. Looking at number 4 now. What's an example of a function whose graph has no x-intercepts? Well, okay, What is an x-intercept? If I have, let's say, a quadratic, the x-intercepts are the places where it hits the x-axis. So some of the answer choices are talking about lines. So let's talk about lines. If a line has no x-intercepts, if it never hits the x-axis, that means it would be also parallel to the x-axis. So it'll be a line that looks like this. So a linear function whose rate of change is 0, because if I'm horizontal, if a line is horizontal, it has a slope of 0. A line whose rate of change is 0 would have no x-intercepts. So A is wrong. A quadratic function with zeros, well, guess what zeros are? They're x-intercepts. So then, of course, it has x-intercepts, so it doesn't fit what they're asking. A quadratic function with no real zeros, what are zeros again? They're x-intercepts. So no real zeros means no x-intercepts, and the answer is C. So at its heart, this is simply a vocabulary question. And just to quickly look at choice D here, we're talking about a cubic. Now, what's a cubic polynomial? Something like y equals x to the third. It'll have a shape like this. A nice simple cubic function of y equals x to the third would look something like that. Just adjusting here. Okay, so a cubic polynomial will definitely have an x-intercept because it goes infinitely up and down. So at some point, it would be crossing the x-axis. So the answer to number 4 is going to be C. Number 5. Number 5 is telling us that x equals 9. So let's plug that in. Square root of k plus 2 minus 9 equals 0. Add 9 to both sides just to get the radical by itself. On a radical equation, you want to isolate the radical. And that'll allow you to square both sides. So now we can square both sides. It'll give us k plus 2 on the left and 81 on the right. Take away 2 from both sides. We'll get 79. And the answer to number 5 is D, 79. Number 6 here is asking us for the sum of these two expressions. So a squared minus 1, a plus 1, and we're adding them together. So when you're combining like terms, you can only combine numbers that are combinable. So the a squared and the a, then we have 1 and negative 1, which cancel each other out. When we add them up, we just get 0. So really, this is a squared plus a plus 0, which is the same as choice A here. Looking at number 7 now. This tends to be the kind of question that people think of as a word problem, but there are plenty of really long problems on the SAT. The longer the problem, particularly if it's a system of equations, like where they're telling you X stands for this and Y stands for that, you want to be really firm on what they're talking about. So it doesn't hurt to write it out. X is the number of hours she tutors, and Y is the number of hours she spends as a lifeguard. So now that we spent just an extra moment describing what our variables stand for, it puts us in a better position to kind of make sense of it, because the question says she can work no more than 20 hours per week. So the total number of hours, which is X plus Y, can't be more than 20. It can be equal to 20 and it can be less. So less than or equal to. The amount she's going to earn needs to be 220 per week. So it can be equal to 220 or greater than 220. So greater than or equal to. And for the amount of money earned, that's going to be our price times quantity statement. If you watch a lot of our videos, you hear about price quantity combinations all the time. It's the fundamental unit of money and of general multiplication. because these statements don't always relate to simply money situations. But for this situation, she's making $12 an hour as a tutor. So the amount of money made is going to be 12 times the number of hours tutored. And for the lifeguard, she makes $9.50 times the number of hours as a lifeguard. So 12x plus 9.5y. So we've got x plus y less than or equal to 20, 12x plus 9.5y greater than or equal to 220. And now we can just go ahead and match that with one of the equations. So we want a less than sign here. So that gets rid of choice A and choice D. And we want 12x plus 9.5y greater than or equal to 220. So this less than has to go. So for number 7, the only choice left standing is C. Now we're going over to number 8. So 8 is asking us for the interpretation of the number 331.4. So what we can notice is that this expression is in a y equals mx plus b format. It's 0.6t plus 331.4. They match up. So what's the 331.4? Let's write them side by side. S of t, which is the same as y, is 0.6t, t is our x, plus 331.4. So what's the 331.4? It's the b, the y-intercept. So now this graph that they're giving us, it's got the speed of sound is a function of the air temperature. So the temperature is the thing that's going to kind of change no matter what. It's going to change independently. It's the independent variable. And the speed of sound is the thing that's a function of t. It's a function of the independent variable, which is what y is always in equations like this. So you've got s and t right there. And the question is saying that it starts at 331.4. So that'll be your 331.4 and increases at a rate of 0.6, whatever that is. That's our slope. So what's the 331? It's the starting s, because b is going to be our starting y value when x is 0. So here, 331.4, let's make that a little more beautiful. 331.4 is our starting s when t is 0. And what was s again? It was the speed of sound. And what's t again? It's the temperature. So in our words, 331.4 is the speed when the temperature is 0. And that sounds a lot like choice A for number 8. Now we're going over to number 9. Okay, so xy is a solution of the system above. X is greater than 0. So first of all, a little word about the disclaimer of x being greater than 0. To me, in a quadratic situation, that's a little bit of a hint that there are two solutions for x, because they're telling us that when you get those solutions, pick the one that's greater than 0. So that's kind of what that's all about. But when you have a system and you're being asked for a solution, we want to interpret that as the intersection. And when you're asked for the intersection of two functions, whether it be quadratics or otherwise, we would rather get that, in our opinion, by getting both equations in a y equals format and setting them equal. Now, if these don't work in a similar situation, then we're going to want to go ahead and substitute is the next thing. But just having done so many SATs and tutored on the SAT for such a long time, I can tell you that, leaning toward getting both equations in the y equals format and setting them equal is kind of a nice, simpler way to get the questions done that tends to result in less mistakes. So here we already have y equals x squared. That's already in the y equals format. Let's go ahead and do the same for the other one. So 2y plus 6, distribute that to 2x plus 6, take away 6 from both sides, 2y equals 2x, divide both sides by 2, y equals x. So once we start simplifying the second equation, we see that this is actually kind of easier than we thought it was going to be. So y is equal to x. And let's go ahead and do what we said we were going to do, which is get them both in the y equals format and set those equal. So one of them is equal to x squared. The other y is equal to x. That looks almost like we made a mistake, but it's actually correct. We have x squared equals x. Now, in order to not lose a solution here, we still have to be careful to treat this like a quadratic. Quadratics are solved by setting one side equal to 0. So take away x from both sides. Factor out the common factor of x. Set both of these equal to 0 because right now we have the 0 product rule. This times this equals 0. The 0 product rule says you're allowed to set them both equal to 0 and add 1 to both sides, and x equals 1. So x equals 0, x equals 1. Those are our two solutions there. And just one more thing to talk about. Well, okay. First of all, the question told us that the answer to pick is going to be the one that's greater than 0. So this one's equal to 0, and we're picking the one that's greater than 0. So x is going to be 1. Before we move any further, though, it's really important to talk right here about two-step quadratics. Two-step quadratics. So, apologies, two-term quadratics. So we have two terms. We have x squared and x. And that's different. Normally we have three terms with a quadratic, right? And we can do BC factoring, ABC factoring, quadratic formula, completing the square, different methods. But when you have two terms, there you want to lean toward using the GCF. So we kind of instinctively here just use the GCF. We took out an x and it left us with x minus 1. But it's very important to let the listeners know that this is what you should be leaning toward. Anytime you have a quadratic with two terms, it's usually a GCF situation. So back to solving now. We know that x is 1. We'll plug it into maybe the easier of the two equations. Y equals x squared. So y equals 1 squared. And therefore, y equals 1. This is the solution we got. Now, if we plugged in x equals 0, y would now equal 0 as well. But we're interested in the positive one because they told us that x was positive right there. So y equals 1 and x equals 1 and x times y is 1. And we are done with number 9. Going over to number 10 now. 10 is giving us some equations here and asking us for 4z plus 8y. Well, z is a squared plus b squared. And y is ab. Distribute a little. Now, we're going to be rewarded in this situation for identifying a perfect square. Now, it just seems to me like I'd want to take out a GCF, but looking at the answer choices, there are none that have a greatest common factor off to the side. So instead of that, we can tackle this from the perspective of a perfect square. Now, what is a perfect square? It's something that looks like this. X plus y squared is the same as x plus y times x plus y. And if we do first, outer, inner, last on that, we get first times first, outer times outer, inner times inner, last times last. And this is what always happens. The outer and inner terms double up. So doubling them, you get x squared plus 2xy plus y squared. And so what we're talking about is identifying. If I have something that looks like this, then it's a perfect square and it factors this way. It factors to x plus y squared. Now, taking that a step further, there's something that we refer to as the perfect square test. The perfect square test would allow you to test out the components of a trinomial quadratic and determine if it needs to be factored as a perfect square. So in order to do that, the first term must be a perfect square. So for our x squared, the first term was x. Next, the third term must be a perfect square. So the square root of y squared is y. Last but not least, the middle term has to equal 2 times each of those numbers you just found. So 2 times x times y. And notice that the middle term is equal to 2 times x times y. So we just went through the 3 steps or the 3 criteria of figuring out if something's a perfect square. And so if that's all the case, if it's all correct, the first was a perfect square, the third was, the middle is equal to 2 times x times y, then it factors to each of those first 2 things that each of these first 2 square roots that we took. So x and y squared, and I didn't put the plus sign in the middle. The thing to know about that is if you have a plus sign here, then you'll have a plus sign in the middle. But if you had a negative sign in that same spot, you'd get a negative sign in the middle. So this will be x plus y squared for our, for our example here, which makes sense because we started by saying it's x plus y squared. We FOILed it out to prove that you get this, and then we showed that you can actually use factoring. If you didn't already know it was equal to x plus y squared, you could use factoring to get there. So similarly here, how do we know this is a perfect square? Very tough to kind of identify this, but you need to practice to the point where you would be able to, because it's one of the critical things that comes up on the SAT. We have a perfect square here, a perfect square here, and then something that looks like it's equal to 2 times the square root of each of those terms that I just circled. So let's reorder it in the way that we see more frequently for a perfect square. So once we're suspicious that this is a perfect square, we want to kind of write it in the order that you see them. So our prototype example is x squared plus 2xy plus y squared. And so notice the kind of similarity, 4a squared plus 8ab plus 4b squared. It's got the same general shape to it. So is the first term a perfect square? Well, yes, because the square root of 4a squared is 2a. Is the third term a perfect square? Yes, because the square root of 4b squared is 2b. Is the middle term equal to 2 times each of those terms that we just found as square roots? 2 times 2a times 2b. And in fact, it is. It's equal to 8ab. And so we have all 3 criteria of a perfect square trinomial, and it'll factor to each of these numbers, 2a and 2b, all squared. And the sign just basically has to match whatever we get right here. So if it's positive, then we put a plus sign right there, 2a plus 2b all squared. And the answer to number 10 is B. Going over to number 11 now. Volume of a cylinder is 22. What's the volume of a cylinder with twice the radius and half the height? We refer to this as changing levels. Changing levels questions will often sound like, if I have a rectangle and we increase the length by 30% and decrease the height by 20%, then by what percent does the rectangle area change. And so, there's a general format. So let me just give you the sort of practice problem I just imagined here. So I have a rectangle, make up new numbers. The base goes up by 40%. The height goes down by 30%. And the question will say, by what percent did it change? So just imagine that the area of a rectangle is base times height, or length times width. So we'll call that A1. This is just an example I made up to show you this concept, and then we'll apply it to question 11, which is a little tougher. So for the new one, increasing something by 40% is the same as multiplying it by 1.4. We talk about that a lot in different videos, so we'll just put that in as a given right now. So 1.4b represents an increase of 40%. And decreasing something by 30% is like 100% minus 30% brings us to 70%. So that's 0.7. So decreasing something by 30% is the same as multiplying it by 0.7. So you've got 1.4b plus 0.7h. And if we were multiplying that out, we would get 0.98 BH. And 0.98, that's in decimal form. That's the same as 98% of BH. So we started at 100% of BH, because anything really is 100%. 100% of you, if you're listening, is listening to this video right now, because numbers just naturally start at 100%. But then we go over to 98%, which means a loss of 2%. So that's the changing levels method. This question here, we can do the same exact thing. We know from our formula sheet that's given in the beginning of the SAT that the volume of a cylinder is pi r squared h. Now, the volume of the new cylinder that they're talking about has twice the radius and half the height. So just based on that, we can get a lot of information. We purposely haven't used the 22 yet. One of the big skills can often be the idea of knowing what information to use now and what information to use later. It's a very advanced thing that you can only build through lots of practice. So square the 2r and you get 4r squared times h over 2. So now in terms of the numbers, we've got 4 over 1 right here and 1 over 2 right here. So 4 over 1. So 4 over 1 times 1 over 2 is 4 over 2. So we'll just have the number 2. 2 pi r squared h. So now what happened in this story? We started with pi r squared h and we ended with 2 pi r squared h. So we doubled. And so now, if the original volume was 22, the new volume will be 44. Going over to number 12 now. 9 to 3/4. Okay, when you're dealing with exponents, you generally would want the most prime base. You want your primest base to be able to handle these the easiest. So if we have 9, I'm going to want to turn that into 3 squared. 3 is the prime base of 9. 9 is really 3 squared. And it's that to the 3/4 power. Now, exponent rules in that situation say if I have a to the b to the c power, we're supposed to know that that's where you multiply. So this is 3 to the 2 times 3/4 power. So now what's 2 times 3/4? Well, it's the same as 2 over 1 times 3 over 4. And before multiplying, I might cross simplify, divide those both by 2, and I get 1 and 2. And so now I have 3 over 2. So the answer is 3 over 2. But how do we relate that to the answer choices? So we went through one exponent rule so far. Another very important rule is that if I have the b root of a to the c, I still have my a to the c format, but that b sneaks around on the bottom. The index of the radical becomes the denominator when you have it in a fractional exponent form. So similarly here, 3 to the 3 over 2 is the same as 3 to the third with a 2 right here. But if there's a 2 in that spot for square roots, we don't write anything at all. So having nothing in that spot is the same as having a 2 in that spot, one of the little confusing things about math. But if it were the third root or the fourth or fifth root, we would have 3, 4, or 5 in that spot. Now, simplifying a square root, the idea of having the 2 right here, means that any factor that multiplies by itself twice underneath comes out of the square root. So under the square root, we have 3 times 3 times 3. And we're looking for groups of 2 that we can take out and leave as a single number on the outside. So by doing that, we just took the square root of the 3 times 3. We asked ourselves, what number multiplied by itself gives us that 9 that we circled in red? 3 times 3 is 9. And what number multiplied by itself gives you 9? And the answer is 3. So here we have a 3 on the outside and a 3 on the inside. And the answer is D, 3 root 3. Going over to number 13 now. Okay, there are a lot of ways that 13 can be handled. You can kind of invent numbers and test this out. Very subtly confusing here because there's T is the number of tea bags, but N is kind of the word number, and T is kind of the number of tea bags, and N is T, and T is number. So there's a great deal of purposeful confusion between the letters T and N in this situation. In any case, we have a y equals mx plus b situation. They're calling it T equals N plus 2. So a tiny part of that is that there's an invisible 1 right there because there's nothing in front of the N, and there's no such thing as that. If you don't see a number there, it's really the invisible number 1. So we know that the slope is 1, the y-intercept is 2. Why do we care? Because we're talking about the additional amount that's needed to make an additional amount of that. Additional this for additional that, what does that sound like? That sounds like change in y over change in x. We wouldn't know that if the SAT didn't ask about that so incredibly frequently. There are so many different code words on an SAT that are really code for slope. So we'll go ahead and say our slope is our change in y over change in x. And in this problem, y is really the tea bags, the change in the number of tea bags for every change in the x of this problem, which is n, and n is the number of cups of coffee. Now, when you do this, this is the method that we refer to as translating slope. We took the slope formula and we translated it into the words of this problem. But if we're translating slope, then usually the denominator is the number 1. So one way to think of this is the amount of tea bags you would need for every 1 cup of coffee. And that's because if I have a number in that spot, any number like 5, for instance, is really itself over 1. That's why we're randomly putting a 1 on the bottom and some unknown number on the top. So we translated the slope, and it's the number of tea bags for each additional 1 cup of coffee. Now look how coincidental this is. What is the additional number of tea bags needed for each additional cup of, you see, I said coffee there. I think I just gave myself away as a coffee drinker, but it's tea in this problem. So what is the number of tea bags needed for 1 additional cup of tea? Well, it's the slope, right? And the slope from the beginning was the number 1, or 1 over 1. Same thing. So how many additional tea bags do we need for 1 additional cup of tea? The answer is 1. Very confusing with the way that the t relates to n here, the n relates to t. with the way that the slope is just the number 1. It's amazing the way that the SAT comes up with its strange flavor of difficulty. Let's look at number 4 now. Number 14 now. Okay, number 14 is giving us a lot to zoom out and look at here. Message brought to you from Microsoft. OneNote is such a great, helpful program that allows me to do what I do, but it does have some bugs these days. I'm going to take these answer choices and put them next to the other two so we can be able to zoom in more easily. Okay, deep breath. Here we go. So I just brought choices C and D a little more close so we can see better. Okay, so we're looking for here y equals negative f of x. So that negative sign there says take everything in f of x and multiply it by -1. So let's do that first. Negative f of x equals negative 2 to the x minus 1. So far, so good. Now, we're dealing with an exponential function. Exponential functions have 0 in the x, or have x in the exponent spot, and the number 0 is actually quite important here. When you have x here, you have to think about the 0 exponent. The 0 exponent matters a lot in graphing because anything to a 0 power equals the number 1, right? 5 to the 0 would be 1, or 10 to the 0 power would be 1. So we can plug in 0 here to figure out what the y-intercept is, because when x is 0, when you need the y-intercept, x is 0. That's one of our sayings. So negative f of 0 equals negative 2 to the 0 minus 1. 2 to the 0 is just 1. So this is negative 1 minus 1. That adds up to negative 2. And which of these graphs, when x is 0, has a y value of negative 2? There's only one that does that. So the answer to number 14 has to be C. Now moving on to the incredible question number 15, which I'd love to hear the opinion of other test prep tutors out there, but I get the feeling that this question type is not being featured so much on official SATs that I've seen lately. It's almost like they realized that they went a little overboard with this situation. It's essentially a fancy unit conversion question. And it's just so heavy on variables. So what we're going to do here is we're going to create a model of what they're talking about and use that as a blueprint for what we need to solve. So Alan drives 100 miles in a week. His car goes 25 miles per gallon. So that's 1 gallon over 25 miles. And in our chemistry style unit conversions that we like to do, we emphasize heavily that this parentheses here is nothing more than the number 1. Because if 1 gallon gets you 25 miles or 25 miles gets you 1 gallon, in the story, they have the same value as each other. And when you have a fraction with the same number on the top and the bottom, it's equal to 1. So we're converting the 100 miles into something that's equivalent to 100 miles in terms of how many gallons you would need by doing this. So we'll ignore the next line here, but because we have easier things to deal with. Gas costs $4 per gallon. So once again, we're putting the gallon on the bottom because we already have that unit on the top. We need to make it cancel. So instead of saying 1 gallon over $4, we'll say $4 over 1 gallon. If we go ahead and multiply that out, well, the miles cancel with miles, the gallons cancel with gallons, and we have 100 times 4 over $25. The big part of this is that whatever number we end up with is in dollars. And by the way, it would be whatever you would get for 100 times 4 divided by 25, which would actually be the number 16. Now, the question says we need to reduce the weekly expenditure by $5. So we have $16, and you know, maybe the first time I saw this problem, I converted this to an 11 because we want to reduce the expenditure by 5. But with the way the answer choices are set up, what they're actually asking is what setup of this is equivalent to $5. And like I said, I only figured that out by being wrong on the way of seeing this that would really make more common sense. So we're removing the 16, replacing it with 5. We still have the 100 miles each week. Actually, we don't have that. The question is saying we're going to now be doing M miles. So the 100 comes out and M comes in. But we still have the 1 over 25 for that conversion. And we still have the 4 over 1 for this conversion. But like I said, we're trying to figure out what use of all this results in $5, which is what we're looking for. So which equation can be used to figure this out? You're looking at it. It has a 4 and an M on the top and a 25 on the bottom equals 5. And that looks a lot like choice D. 4 and M on the top, 25 on the bottom, all equal to 5. If that is a little hard to understand and follow along with, I'll just kind of say, yeah, I agree with you. It's a really unique question type with the unit conversions all done in variables with a statement that it's asking that's almost a little tough to understand. So I would chalk that up to the question. As long as you know how to perform unit conversions and you know how to deal with variables, you have a good chance of answering a question like this. I really do think that this is just a unique question in and of itself, not necessarily something that we need to really be ready for in the future. Going to number 16 now. Maria will be renting a boat, and the boat rental costs $60 per hour. She'll have to pay for a water safety course that costs $10. She wants to spend no more than $280. So this is a nice y equals mx plus b setup. It costs $60 per hour. So the hourly cost is $60. So the course is $10. That's a one-time cost. But the $60 per hour is $60 every hour. So 60 times x. So the one that changes with every additional hour, that's your slope. And the starting number, that's your y-intercept in all of these situations. But this can all, okay, so this is our equation, 60x plus 10. And it needs to come out to no more than 280. So it can be less than 280 or equal to 280 because it's no more than 280. So now we have something to solve. Take away 10 from both sides. Divide both sides by 60. And I'll kind of do this out by hand because this is the non-calculator section and you wouldn't really be able to use a calculator here on a real test anyway. But 270 over 60, we can simplify that to 27 over 6. Divide both sides by 3, 9 over 2. And that gives us something that we can now make sense of, 4.5. So x has to be less than or equal to 4.5. When they say what's the maximum number of hours, they're saying what's the maximum whole number of hours. So if x is less than or equal to 4.5, what's the maximum integer there? and the answer would simply be the number 4. Now, for anyone that needs to see that kind of visually, we knew that x was less than or equal to 4.5, so that gives us a dot right here at 4.5, and the graph goes in the lesser direction. So the graph kind of looks like this. So what numbers are going to be around 4.5? Maybe 5, 4, 3, and so on. So what's the maximum integer number that fits on this number line on the solution that we have here? The maximum integer number is 4, right around here. Definitely not 5. Going over to number 17 now. Zooming in a little bit. What value of P is the solution of the equation above? Distribute, just kind of go into autopilot here. Distribute again. Now combine like terms. 2P and 8P is 10P. 2 minus 8 is negative 6. Take away 10P from both sides. Divide both sides by negative 5. And a negative over a negative is a positive, so P is 6 over 5. Now let's try number 18. So this system has a solution xy. What's the value of x? So we said we want to get both in the y equals format and set those equal. We've also said for systems of linear equations that if the x's, y's, and numbers line up, that's the elimination method. And if it's easier to get y by itself or x by itself, that's the substitution method. So this would maybe logically be the substitution method. And we can sort of try either one here. I think I just generally like the idea of getting them both in the y equals format. So let's go ahead and take this equation and multiply both sides by 2. That's going to undo the left-hand side, leaving you with 2x plus y equals 21. Take away 2x from both sides, y equals 21 minus 2x. So right now we have y equals this given, and y equals this. We just figured it out. So 2x equals 21 minus 2x. Add 2x to both sides. Divide both sides by 4. Fix that. Divide both sides by 4. X is 21 over 4. And that's one of the possible answers for number 18. 21 divided by 4 as a decimal will be 5.25. And that would be accepted as an answer as well. Going over to number 19 now. A is a positive constant, okay, and we need the value of A. So the idea is like how to bring this all together. And the answer is we need the same denominators. So what can we do? We can multiply by x plus 2 over x plus 2 because we have x plus 2 squared here. And with the extra x plus 2, we'll have x plus 2 squared here as well, because x plus 2 times x plus 2 is x plus 2 squared. Now, once again, we're allowed to do that because this is just the number 1 right here, and we're allowed to multiply anything by the number 1. It's not going to change anything. So we have 2x plus 6 minus 2 parentheses x plus 2 over x plus 2 squared, which is what we want because the answer says it needs to be over x plus 2 squared. So just being a little careful to distribute. the right way. 2x plus 6 minus 2x minus 4 over the x plus 2 squared. And 2x minus 2x cancels to 0. 6 minus 4 is 2. And you have 2. So we were being asked for a over x plus 2 squared. And now we have 2 over x plus 2 squared. So a is 2. Now we're going over to number 20. Okay, so right here, we see a linear pair. We have this angle in blue, and we have this angle in green. And those angles there are sort of back to back with one another, and they form a straight line. So they add up to 180. That's the idea of a linear pair. So 106 plus 74 has to add together to give us 180, and it does. Now we have the idea that the three angles of a triangle also add up to 180. So 74 and 23 is 97, and we need 83 more to get it to equal 180. 74 plus 23 plus 83 equals 180. So now we have another linear pair situation because we have now this blue angle and this green angle. So x and 83 have to add up to 180. So 180 minus 83 is 97. And so what we're saying is that 97 plus 83 equals 180. And so therefore x is 97. So that's the answer to number 20. Thanks so much for joining us. Stay tuned. I believe we'll be doing SAT Test 5 Section 4 in our next video. Thanks so much for joining us.